All right, now we're going to take a look at a couple problems that have to do with describing the relationship between two variables. In this case, it'll be x and y. So let's take a look at number 6 from the homework problems. It says, when Jared is 7 years old, his sister Megan is 11 years. When Jared is 9 years old, Megan is 13 years. And it wants us to write an equation to describe the relationship between Jared's age, y, and Megan's age, x. So if I take a look at Jared's age, and I'll take a look at the first one, it says when he's 7 years old, Megan is 11 years old. And I'm just going to take a peek at this relationship real quick. So I look at these two numbers and I say, well, what do I need to do to get from 7 to 11? And one thing that I could do is I can add 4 to get from 7 to 11. If this is actually the pattern, I need to verify this by looking at the other situation. So if I look at the other situation, it says when Jared is 9 years old, Megan is 13 years old. So I'm going to do the same thing. I'll write 9 and I'll write 13. And then I'm going to zoom in here and I'm going to say, well, do I have to add 4 to 9 to get to 13? And yeah, 9 plus 4 is 13. So we can see now that the pattern here is if we add 4 to Jared's age, we get to Megan's age. And so if Jared's age is y in this example, whoops, wrong color, and they're calling Megan's age x, then I can say Jared's age y plus 4 will give me Megan's age x. Or if I wanted to, I could say, I can kind of go backwards and say, well, if I have Megan's age and I take away 4, that's going to give me Jared's age. So both of those equations would be totally acceptable to describe the relationship between Jared's age and Megan's age. Now let's take a look at the problem below it. This one I think may have been the trickiest problem on this homework. So let's go ahead and do this one together. The first thing I do is I'm going to look at this table. And when I look at this table, I see a bunch of X's and a bunch of Y's, and I'm trying to figure out what in the world is going on here. What is the relationship between these X's and these Y's? And a lot of students got stuck on this one, and that's totally fine because they're giving us a little bit of a curveball here. If I look at these X values right here, if I look at these X values, they're not actually in order. It doesn't go -3, then -2, then -1, then 0, then 1, then 2. It actually skips a couple. So what I'm going to do first is I'm going to rewrite this table over here, but I'm not going to skip anything. I'm going to write -3, and then -2, and then -1, and then 0, and then I need a little more space here. 1, and then 2. And I'll fill in what I know. When x was -3, it says that y is 7. And I'll label these just so it's clear. We don't have -2 yet, but we know when x is -1, y is 15. When x is 0, y is 19. And when x is 2, y is 27. So now what I want to do is I want to look and see if we have some kind of common difference here. And I'm missing some values, so that might be a little bit tricky, but let's take a look at it together. When x is -1, y is 15. And the next one we actually have. When x is 0, y is 19. So if I look at this relationship here, I see that it's a +4 right here. So what I need to do to check and see if this could potentially be an arithmetic sequence, what we've been talking about for the last couple of days, I need to actually go to the next one and then go to the one after that and see if I can get there by adding 4. So if I add 4 to 19, that's going to give me, I'll write it in here, 23. And then if I add 4 again, 23 plus 4, that gets me to 27, which shows me that there is an arithmetic sequence going on here. But just to double check, I'm going to work backwards from 15 to go from when x was -1 to here when x is -2. And I'm just going to do the opposite. Instead of adding 4, I'll subtract 4. That takes me to 11. Oops. And then if I go back again, that gets me back to 7. So it worked. So what this tells me is that there is a common difference of 4. So I'll say our common difference is 4. Now we're almost there in terms of describing this relationship with an equation. We just need to figure out, okay, well, where do x and y play into this? And if you recall from one of our classroom meetings, we talked about the importance of looking at what happens when x is 0, or the 0th term in our sequence. And we see that when x is 0, y is 19. Y is 19. So we can use that to help us. What we can do is we can say, let's take the common difference of 4 and multiply that by our x value. And we know that if I were to do that, 4 times, let's say 0 for x, I would just get 0. But what I need is 19. So I have to ask myself, well, what do I have to add to 0 to get 19? I have to add 19. So by looking at what happens when x is 0, we find this constant value right here, and I'll highlight it for just a second. We find this constant value that we can add to our equation to help us get from x to y. Our common difference is always going to be the value that we multiply by x. And this really shows us the relationship between arithmetic sequences and linear equations. If you recall from middle school, this is a type of linear equation. It's a linear equation written in slope-intercept form. So I'll get rid of this highlight. Oops. And what we need to do still is check and see if this equation works. So let's pick another value. Let's pick this one right here. When x is 2, y needs to be 27. If I plug in 2 for x, that would give me 4 times 2 plus 19. 4 times 2 is 8, and 8 plus 19 is for sure 27. So what we just did was we verified that this equation will work for another set of values in our table. And after that, we're done. So this will be our equation that we use. 4x plus 19 equals y. This is definitely the hardest problem on the homework, in my opinion. You will not be quizzed on this one, but if you were to study this one, it would definitely help for the test that's going to be coming up at the end of the unit. All right, thank you.